Hi 7th graders, I hope you've been doing well. Today we're going to continue Unit 4, which is all about interpreting graphs. Our learning target for today is I can describe a set of data using a line graph. Alright, so let's get started. Our first example, we need to create a graph for the following situation. So every morning, Tom walks along a straight road from his home to a bus stop. This table shows his journey on one particular day. Use it to create a graph and then answer the following questions. Alright, so if you notice, they already labeled everything and they put our scale on our graph. So our time is our x value, that's in seconds, and our distance is our y value, and that's in meters. Alright, so let's get started. Our first point that we need to plot is 0, 0. Alright, so that's an easy one. That's just right down here at the bottom. Our next one is 20 seconds and 40 meters. So we're going over 20, up 40. So right there. Our next one is 40, 80. So we're going over 40, up 80. And then 60, 40. So we're going over 60, up 40. Alright, next is 80, 100. So we're going over 80, up 100. 100, 160 is the next one, over 100, up 160, and lastly 120, 160. So here's 120. Alright, so your graph should look like mine. Now we're going to do our best at connecting these lines, okay? Connecting these dots by drawing lines. So we're going to do our best at connecting them as straight as you can. It's okay if it's not perfect. Alright, and we have our graph all done. So now we are going to answer these questions down here to understand this graph and to really figure out what's been happening. Okay? So our first question, what is the label on the x-axis? Well, our x-axis is our horizontal one, and that is time in seconds. Time And then number 2, what is the label on the y-axis? Our y, remember, is our vertical one, and it even has a y next to it, so it helps us remember. And that is distance from home in meters. Alright, number 3. Where is Tom at the beginning of the graph? Alright, so if you notice, right at the beginning of the graph, Tom is at 0, 0. So that means at 0 seconds, before he's left, he's at 0 meters. So if you notice what our y-coordinate, or our y-axis is, it's distance from home. If he's 0 distance away from home, that tells us that he's at home. So number 3, Tom is still at home. He hasn't left his house yet. Alright, number 4, how many parts does the graph have? Label them A, B, C, D. Alright, so when we look at this graph, we want to notice when it changes. Alright, so if we're walking on this line, we're steadily increasing from 0 to 40 seconds. Okay, so that is part A. Okay, now let's go to the next section. Now, we're at 40 seconds. He walked back towards home. So that is part B. Okay, our next section, at 60 seconds, now he's continuing to walk back away from home. So that's part C. And lastly, our last part, from 100 seconds to 120 seconds, he's just standing in one spot. He's not moving anywhere, he's just standing there. He's waiting for the bus. So A, B, C, D, make sure you label your graph just like I did. Alright, so now number 5 is asking, oops, I forgot to answer number 4. There were 4 parts. kind of did that while we were looking at our graph. All right, number 5, we need to figure out in which part is the graph going up. All right, so if you look at our line, when is our line increasing? There's 2 parts it's increasing. It's increasing from 0 to 40 seconds, so at part A, and it's also increasing from 60 seconds to 100 seconds, so part C. All right, now number 6 asks, in what part is the graph going down? Well, when is our line decreasing? If A and C was increasing, at line B, it looks like our line is going down, so that is number 6. Number 7 asks, are there any parts where our graph isn't going up or down? Well, if you notice, there's a straight line at D. It's just flat. Tom's not moving, but time is still going by. So that is our where it isn't going up or down. All right, and now our last question. In which part of the graph is Tom moving the fastest? So when we look at this, we obviously know he's not moving the fastest at point D because he's not moving at all. So we know we can ignore that part of our graph. So now we need to look from parts A, part B, and part C and figure out when our line is the steepest. Okay? So let's just look at this a little closer. Part A, from 0 to 40 seconds, he's moving 80 meters. Okay, so 0 to 40, he's moving 80 meters. And then from 40 to 60, he's going from 80 to 40, so that's another 40 meters. Okay, in our last section, section C, from 60 seconds to 100 seconds, he's moving from 40 meters all the way up to 160 meters. So that's 120 meters total. Okay, so over that length of time, this number is obviously the biggest, right? 120 is bigger than 40 and bigger than 80. But our line is a lot steeper than it was at part A and part B. So Tom is moving the quickest at part C. Alright, so we just created a graph and we answered a bunch of questions to help us better understand that graph. Now let's practice a few more. Alright, so now we're going to match different graphs to different situations. So the following graphs show the distance Tom is from his house. Determine the correct situation for each graph. Alright, so let's just take a look at these graphs. Our bottom is the time, and our y-axis is the distance from home. So again, right here at 0, 0, that's at home. So just keep that in mind. This graph is very similar to the one up above. Okay, this next one is exactly the same. Distance from home and time. This right here is home. Same with number 3. This right here is home, time, and distance. Alright, so now we need to read these situations and we need to figure out which graph is showing this exact situation. So number 1, Tom took his dog for a walk to the park. He set off slowly and then increased his pace. At the park, Tom turned around and walked slowly back home. Alright, so in this part, we're kind of thinking about 3 different sections. He set off slowly. So if he's moving slowly, that means the line isn't quite as straight up as if he was going quickly. Okay, so if he's starting out slowly, then he's going to increase his speed. So that means he's going to get a little faster. He's still walking away from home, so that means the line's going to be a little bit more straight. Okay, and then lastly, at the park, Tom turns around and then he walks slowly back home. So he's turning around and he's going back home. That means he's going to end up back here somewhere. So he's slowly going back home. Alright, so looking at one of these graphs, which graph looks the most like it? Yeah, I would agree, graph 2 does. So go ahead and fill out graph 2 and then we'll talk about it. Alright, so looking at graph 3, we know that it's not this one because graph 3, Tom never comes back home. So we could cross graph 3 off right away. Okay, now trying to decipher between graph 1 and graph 2. If you look at graph 1, Tom is moving pretty quickly right away at the beginning. And then it looks like he slows his pace because that line isn't quite so tall or steep. And then it looks like he goes home really fast and he ends up back home. We want the one where he's walking a little slow, and then he walks a little bit faster to get to the dog park, and then he slowly takes his time going back home. So that was graph 2. Let me erase all my marks. Alright, now let's figure out between graph 1 and graph 3 for number 2. So number 2 is number 2, Tom rode his bike east from his home up a steep hill. After a while, the slope eased off. At the top, he raced down the other side. Alright, so think about when you are riding a hill. You're going up a really steep hill. So that means you're going to need to pedal really hard to get up that hill. Are you going to be moving pretty quickly when you go up that hill? No, you're probably not, because you're probably going to be getting tired as you're going up the hill. So you're pedaling pretty slowly. Okay, so that's this part. Next, the slope eased off. So that means it's not really a hill anymore. So do you think you'll go slower than what you were going before, or faster? Right, you're going to go a little bit faster because you're not working so hard to get up a hill. So our line's going to be a little bit straighter, or a little bit steeper. And then lastly, it's saying at the top, he raced down the other side. Alright, so think about this. If you're going up a hill, and you get to the top, once you get to the top, now you're going downhill. Are you going to go super slow down the hill, or are you going to go super fast up the hill? Right, you're going to go really fast. So our line has to be even steeper. So we need a graph that looks something like this that I drew. Alright, so if we look, graph 1 and graph 3, which one do you think it is? Yes, graph 3, because it never told us that Tom goes back home, so we don't need to expect our line to come all the way back to the x-axis like it does in graph 1. So our answer for number 2 is graph 3. Alright, our last one. Tom went for a jog. At the end of his road, he bumped into a friend, and his pace slowed. When Tom left his friend, he walked quickly back home. Alright, so right away, Tom went for a jog. If you're jogging, you're normally going faster than walking, so I would say our line is going pretty steep. At the end of his road, he bumped into a friend, so he probably slowed down a lot and talked to his friend. So our line isn't going to be quite as steep, so let's make it a little, not flat, let's just make it a little slower slant. And then lastly, after Tom left his friend, he quickly walked back home. So he's coming back down here at the bottom, he's coming back home, and he's walking pretty quickly. So based on all of that, which graph is showing that? Right, graph 1 is. And we know that because he's jogging. He's going pretty quickly. Then he sees a friend, so he slows down to talk to his friend. And then he ends up walking back home quickly. Alright, so that was all about interpreting graphs. I hope that made sense. If you're confused about it, please let me know. I'm more than happy to go through Google Meet with you to make sure you understand it. Otherwise, if you have questions, let me know. Your secret word for today is fish. Have a great day, 7th grade.